Hi, in this video I'm going to talk about ski jumping. To introduce that, I want to start with the monkey and a gun. So I'll let you watch the video, and it's essentially you have a golf ball which is in a rocket, and then you have sort of a monkey which will be attached over here. And this guy will basically use this golf ball to try to shoot the monkey. And what is important is that he's going to aim at the monkey while it's at rest. So he's going to just he's just going to make sure that it's basically just a straight line from the the cannon up to all the way up to the monkey. Okay, and then the trick you'll see is so he's going to put in the golf ball, and then so he basically shoots the ball at the same time as the monkey is released, and by miracle the two are gonna hit each other. Okay, and that's the idea. So he showed two cases, one where it's faster, another one which is a little slower, but every time it will basically shoot the monkey and essentially have the monkey shot. So why is the monkey shot even though the bullet is aimed at the spot where the monkey is released? And so clearly you're aiming at a spot where the monkey is gone. So is it because the gun is triggered before the monkey is released? Is it because the gun is triggered at the same time as the monkey is released? Or is it because the gun is triggered after the monkey is released? So what is the answer? And I guess the correct answer is B. And so let's see why. Is basically both of them, both the bullet and the monkey will fall down with the same acceleration. So even though and it's independent of the speed of the gun. So if the golf ball would be going, like, let's say at much higher speed, so that the monkey would not have been able to fall down much longer, then it would basically hit the monkey right at the beginning. But since the golf ball is a little slower, it will also curve down with the gravity, but the monkey will also go down with the same acceleration. That's why they eventually hit together. So this is, what I like about that example is that it's sort of a nice illustration of the effect of gravity. And this is going to be quite relevant for ski jumpers. So when you think about a ski jumper, what do you think is the longest distance a ski jumper can do? Is it going to be less than 100 meters? Is it somewhere between 100 and 200 meters? Is it between 200 and 300 meters? Or is it over 300 meters? Okay, so I'll let you think about it and keep your answer in mind, and then we'll look at what actually happens. What is the ski jumping record? Okay, so here we have a ski jumper.
Vor allem im letzten Flugteil da, wo du den brauchst eigentlich.
This is
Österreich hat hier das bislang einzige Mannschaftsfliegen vor einigen Jahren gewinnen können.
And he's flying off at 100 kilometers an hour.
Und der ist noch höher! Der ist noch höher! Das ist Weltrekord! Das muss eine weitere Verbesserung des Weltrekords von Stefan Kraft jetzt gewesen sein.
Das ist ein Wahnsinniger.
Und der steht denn auch. Die Hände waren nicht im Schnee. Wie hoch ist die Weite? 53,5. Gratulation!
Bist du wahnsinnig.
Martin, wir schweigen einmal.
Okay, and let's have a look at the structure. So you see that there's this V shape, and that's sort of many years back they were actually jumping with the parallel skis, but now most jumpers will actually have this V shape, which improves the distance.
Ja, Wahnsinn, vor allem der Mann weitergeschaut hat. Aber nicht den Boden berührt, muss als bestanden zählen. Lupenreiner Weltrekord von Stefan Kraft.
253,5 Meter. Robert Johansson ist Geschichte. Stefan Kraft ist die Gegenwart.
World record of ski jumping.
Unglaublich, was der Kur aussieht.
So let's look now a little bit in more detail of how this jumping works. So what was the clear jumping record? Well, it was 253 meters. So the correct answer is basically C. Okay, so let's have a look now, a closer look at some of the, how you can actually jump. And this is from a paper by Müller, who looked at basically the physics of ski jumping. And there's an interesting aspect, an anecdote about ski jumpers is that they have actually an incredibly low body mass index, which is just the mass divided by the height squared. And then, so if you think about it, this guy who got or some of these jumpers, this is an example of one of them. He had a height of 1.73 meters, but only a mass of 49 kilo. And so this is sort of common problem in ski jumpers, that they need to be long but very light. And so a lot of them actually have eating disorders, which is not sort of so it's not a very healthy sport in that regard. So let's look at sort of a little bit the physics behind that. And so you have here the wind, which is the W. So that's basically when the skiers is falling down. That's the angle at which the effective wind comes in. And so it's basically a mix of the ski is falling down and going horizontally, and that's why this is the angle, and it makes some angle alpha with the ski. And so this is the first angle of interest. And now the angle is basically the angle of the body with the skis, and that's the angle beta. There's also the curvature of the body, which is what we call here the angle gamma. And then there's basically also the angle between the skis and the horizontal distance of or the horizontal. So those are the angles, and what they look at is these different physical parameters. So let's take alpha h, which is the angle of the ski with the horizontal. And so at first, when you go down the slope has a negative angle with respect to the horizontal, and that's why it's negative. And then when you jump off, it becomes positive, and then slowly over time they try to get that angle to be almost horizontal. And then just before you land, it becomes negative again a little bit. Now that this other angle alpha here, which is the angle of the wind, at first that angle is essentially 0, so you're going in the same direction as the wind, and then eventually that angle goes up when you're flying off. Another one is the velocity. At first you start very slow, and then you go to like 30 or almost 40 meters per second, which is close to 100 kilometers an hour, and that's sort of the velocity when you're flying. And then you have gamma, which is the angle of the body, which is pretty constant, and beta is you start kind of straight, and then you start having the skis almost horizontal with the body, so this angle going down. So that's sort of the general framework of the physical parameters, which describes basically a typical professional ski jump. So I think thanks for watching this video. I hope you enjoyed it, and that's the end. Thank you.